Today, the sky above you probably looks normal. Blue, bright, harmless. But there was a time when the sky turned a sick green and the oceans vanished from entire coastlines. Not in myth, not in a movie, but in Earth's real history. The air grew toxic, storms became violent beyond imagination, and seas shrank back hundreds of miles, leaving cracked basins that smelled like death. Life collapsed. Species fled, mutated, or died where they stood. Civilizations that depended on water watched it disappear year after year until nothing was left but dust and memory. And here is the part that should make you sit up. The clues of that ancient disaster are written in the planet right now, in the rocks, in the ice, in the atmosphere drifting above your city. Scientists have discovered that Earth came close to this catastrophe more than once, and the same signals are appearing again. Rising heat, dying seas, strange skies. If you are watching this in Tokyo before school, or in Toronto before bed, or somewhere else in the world wide awake at midnight, get ready, because what you are about to learn will change the way you look at the air above you and the oceans, beside you forever. You step outside, and the first thing that hits you is the color. Not blue, not grey, not anything a normal sky should look like. It is green. A strange glowing green that feels wrong in a way your brain cannot explain. The sun is still up there somewhere, but it looks weak and pale, like it is struggling to push through a thick curtain. The air feels heavy on your skin, and for a moment you think, this must be a dream or a movie set or some kind of filter someone forgot to turn off. But it is real. You blink and the color does not go away. Your heart picks up because you know deep down that when the sky changes color, something in the world has already gone very wrong. What you do not know yet is that this has happened before, not in a science fiction story or a destroyed future city, but on the real Earth long before any modern human opened their eyes. The green sky was once a signal, a warning, a moment when the planet was trying to tell life that everything was about to change. Today you are just staring up at it, not understanding what it means. That same green shade once meant extinction for entire ecosystems. It meant oceans drying up. It meant the world turning into something almost unrecognizable. You can feel it in the air even now. It is too quiet. No birds, no hum of insects. Even the wind sounds different, like it is moving through a thicker atmosphere than usual. When you breathe in, you catch a metallic taste that makes your tongue tingle and your stomach twist. Something in the sky is not what it used to be. You look around and nothing else seems different yet, but the sky tells you everything. It tells you the rules of the world can change without warning. It tells you that the things you think are permanent can collapse in a single shift of air and sunlight. For a second you wonder if this is the beginning of something that future humans will talk about. Maybe they will call it the day the sky changed color. Maybe they will say it started with people walking outside confused and afraid while scientists scrambled to understand what was happening. It feels like a moment before a massive storm, except the clouds are not building and the thunder is not coming. This is a quieter kind of danger, a creeping kind, that sneaks up on a planet and rewrites its history. A long time ago, Earth went through disasters that made the sky glow strange colors. When massive amounts of gases filled the air, sunlight scattered differently, and the whole sky shifted into eerie shades no human has ever witnessed in real time. The oceans shrank, and the continents dried, and life struggled to breathe. Back then, the world nearly tipped into something no species could survive. You look up again at the green sky, feeling that same ancient warning echo through time. The world has changed before, it can change again, and sometimes it starts with a color you were never meant to see. You probably would not notice anything special about the rock at first glance. It is dull and cracked and looks like something you would kick down a trail without thinking twice. But to Dr. Elias Morin, it is a message from a planet that almost died. He is a climate scientist who spends most of his days hunched over microscopes and sediment cores instead of staring at computer screens in shiny labs. His world is dirt and stone and tiny particles left behind by oceans that disappeared millions of years before the first human learned to make a fire. One afternoon, in the middle of a research trip, he slices open a layered chunk of ancient seafloor and freezes. The colours inside are wrong. They are streaked with pale greens and sickly yellows baked into the minerals themselves. These colours are not normal, not for healthy oceans, not for any stable atmosphere. They are the kind of chemical fingerprints you see when something is poisoning the sky. At first he thinks it is contamination. Maybe a piece of equipment was dirty. Maybe the sample got mixed with another. He runs the tests again and again, and every time the results punch him in the stomach. The oxygen levels in the rock layers plummet at the same moment strange green-tinted compounds appear. They are the kind that form when sunlight passes through an air filled with toxic gases. The same kind that would turn the sky a sickly green. As he keeps studying the core, he sees something else. A sharp boundary where the chemistry shifts from normal, thriving ocean life to almost nothing at all. No shells. No fish remains. No plankton fossils. It is as if the water vanished overnight, leaving entire coastlines dry and exposed. For a moment he wonders if this could be some local event. Maybe a weird lake or a small sea evaporated long ago. But the deeper he digs, the more he finds the same story all over the world. Sediments from Africa, layers from South America, cores from the edges of Antarctica. They all show the same green sky signature and the same rapid disappearance of ocean life. It was global. Something happened to the atmosphere that choked the oceans and stripped away the water until coastlines were nothing but cracked mud and scorching heat. When he presents his early findings, people laugh at the idea. Green skies sound like myths. Oceans drying up in a single geological moment sounds impossible. But he keeps digging, and the evidence keeps stacking until no one can ignore it. These rocks are not lying. They are describing a world that collapsed. A world where the air turned thick and poisonous, and sunlight filtered through clouds of strange particles until the whole sky glowed like a warning sign. Dr. Morin realizes he is not just studying ancient history. He is uncovering the first clue that Earth has already faced disasters powerful enough to change the color of the sky and erase oceans from the map. And if it happened once, it could happen again. Most people think the planet forgets everything because rocks look silent and ice looks empty. But the truth is, the Earth remembers every moment, whether it wants to or not. Every storm, every drought, every breath of ancient air gets locked away in tiny places no one notices until a scientist digs them up thousands or millions of years later. To someone like Dr. Morin, a rock is never just a rock. It is a data file written in minerals instead of ink. When he slices open a piece of ancient seafloor, he is not just looking at colours or crystals. He is reading a memory. Each layer, formed from particles that settled out of water, carrying clues about the temperature of the ocean, the chemistry of the atmosphere, and even the types of living things that were alive at the time. Some layers are packed with shells from tiny plankton that once floated near the surface. Their shells contain oxygen atoms, and those atoms come in slightly different forms. When the climate is hot, one form is more common. When the climate is cold, the other form dominates. By studying the ratios of these atoms, scientists can figure out what the temperature was hundreds of thousands of years ago. It is like finding a thermometer buried in stone. Ice cores work the same way, except they are even more dramatic. When snow falls in places like Antarctica or Greenland, it traps little bubbles of air inside it. Over thousands of years, the snow turns to ice, and those bubbles get sealed away forever. When scientists drill deep into the ice and pull up a long cylinder, they are holding a timeline of the atmosphere. Each bubble is a tiny sample of ancient air, with the exact mix of gases that existed when that snow fell. You can literally breathe in what the world was like hundreds of thousands of years before humans discovered farming. Inside those bubbles are clues to past greenhouse gas levels, past volcanic eruptions, even past wildfires. Some layers contain dust blown in from deserts that grew when climates dried out. Others contain ash from eruptions powerful enough to darken the sky for years. Then there are fossils, which act like snapshots of ecosystems long gone. A single leaf trapped in sediment tells you what plants grew nearby. A tooth tells you what animals hunted or grazed. Even pollen grains, too small to see without a microscope, survive for ages inside mud and lake beds. By counting them layer by layer, scientists can track forests growing and dying as the climate shifted. All these pieces fit together like a massive puzzle that stretches across time. No single clue tells the whole story. But when you combine them, the planet starts talking. It tells you when oceans rose and when they fell. It tells you when the air was easy to breathe and when it was thick with gases that could turn the sky strange colours. It tells you when life flourished and when it struggled to hang on. Reading the planet's memory is slow, careful work, but once you start understanding the language, you begin to see patterns that repeat. You start to see warnings hidden in stone and ice. You discover that the world has changed in ways more extreme than anything you have ever imagined, and that it carries the scars to prove it. Imagine standing on a shoreline that has always felt familiar. Waves that used to crash against the sand are suddenly weak and distant, like they are pulling away from you. At first, you think it is a low tide, but then the water keeps moving back, and it does not return. The ocean is retreating in slow motion, leaving behind a landscape that should never be exposed to the air. The smell hits you next. It is thick and sour, and filled with the stench of things that were never meant to sit under the sun. Layers of seaweed and dead plankton bake into a rotten paste. Shells that once held tiny creatures crack open and release a salty bitterness. The breeze that used to smell fresh now feels like it came from inside a forgotten cave. The ground beneath your feet turns soft, then sticky, then hard as the water disappears. You see patterns in the mud, left behind by ancient currents, ripples fossilizing in real time. Crabs scramble across the drying flats, searching for water that is no longer there. Fish flop helplessly in shallow pools that shrink by the minute. They gasp at the air as their world turns into a desert. But the scariest part is the silence. The ocean always makes noise, no matter what. But when it pulls away this fast, the world goes quiet the same way a room does after a sudden power outage. You feel it in your chest like the planet itself is holding its breath. Millions of years ago, Earth went through a disaster just like this. Scientists call it an ocean recession event, and it was more than just a weird low tide. For reasons still debated by researchers, maybe massive ice growth, maybe changes in seafloor height, maybe a sudden shift in climate, the oceans around the world dropped, not by a few inches or a few feet, but by hundreds of feet. Coastlines jumped outward. Shallow seas that had existed for ages dried into enormous salt flats. Coral reefs that once teemed with colour bleached white, then crumbled to dust. Imagine a sea the size of a small country disappearing in less than a lifetime. You could walk where whales once swam. You could see valleys carved by currents that had existed since before your ancestors learned what fire was. The world would look broken and exposed, like someone had peeled away its protective skin. The air would feel strange too. With less ocean to cool it, the land would heat up faster and harder. Winds would drag the smell of decay across continents. Clouds would form less often because so much water vapor had vanished. Rain would become rare until entire regions dried out. Plants would die, animals would migrate or collapse. Everything that depended on the stability of the oceans which was almost everything, would face the same terrible choice: adapt or disappear. Standing there watching the ocean run from you, you would not know the science behind it. You would just know something was wrong in a way that felt final. The waterline that had shaped life for millions of years was rewriting itself. Earth was entering a chapter where the seas themselves stepped back from the world and left life to face the heat alone. You would notice the smell before anything else. The air would sting your nose with a sharp, burning bite, like someone had cracked open a bottle of chemicals right under your face. Every breath would feel heavier, thicker, almost sticky, as if the air was carrying something it should not. Then you would look up. The sky would not be blue anymore. It would have taken on a greenish tint that feels wrong in a way you cannot explain. Not bright green like a neon sign, but a sick, pale shade like the world is bruised. You might blink thinking your eyes are playing tricks on you, but the colour stays because it is real. The atmosphere has changed and it is showing you the warning in the most dramatic way possible. Long ago, when Earth was going through one of its worst crises, giant volcanoes erupted for years and sometimes even centuries. They poured out gases like sulfur dioxide and methane and carbon dioxide into the air until the atmosphere was no longer the safe mix life depended on. These gases rose into the sky and mixed with sunlight in ways that bent and scattered the light. Normally the sky is blue because molecules in the air scatter blue light more than other colours. But when the air fills with certain particles, that balance changes. Green wavelengths begin to dominate, and the whole sky shifts into a colour that feels alien. Other times the sky turns strange because of aerosols, microscopic droplets created by volcanic eruptions or burning forests or even dried ocean beds. These aerosols reflect sunlight in weird patterns, and suddenly the world looks like it has a permanent filter over it. Sunsets become strange streaks of yellow and sickly green. Even midday light looks dim, like the sun is struggling to breathe through the haze. The temperature changes too. Some of these gases trap heat like a blanket around the planet, turning the atmosphere hotter and heavier. Others block sunlight before it reaches the ground, causing sudden drops in temperature. The planet becomes confused, heating in some places, freezing in others, while life tries to figure out what rules still apply. But the sky is not just a physical thing. It plays with your mind. Humans evolve to trust certain colours. Blue skies feel safe. Grey skies feel normal. Red skies feel dramatic but not dangerous. A green sky does not fit any pattern your brain understands. It triggers something ancient inside you. Your instinct starts shouting that the world is not right, even if you do not know the science behind it. Back in the ancient world, animals reacted the same way. Herds panicked, birds flew in chaotic circles before collapsing. Marine creatures rose to the surface, gasping as toxic air mixed with the upper layers of the water. The whole planet felt the shift, even if it could not explain it. The poisonous sky was a sign of a world under attack by its own atmosphere. Life survived, but only barely. The air is the one thing everything on Earth shares. When it turns toxic, when it changes colour, when it stops behaving like the sky you grew up with, the entire planet enters a danger zone. The green skies of ancient Earth were more than just strange weather. They were warnings written across the heavens, telling every living thing that the rules of survival were about to change. If you were expecting the end of the world to start with a giant explosion or a fireball ripping through the sky, you would be wrong. Real planetary disasters almost never begin with something dramatic. They begin with something tiny, something so quiet and slow that no one notices it until the damage is already locked in. Imagine Earth tilting just a little more on its axis. Not enough for you to feel it, but enough to shift how sunlight hits the planet. Summer gets a little hotter, winter grows a little longer, snow stays on the ground just a few more weeks. Plants take slightly longer to bloom. Animals migrate a little differently. Nothing feels like a big deal at first. But that small tilt starts a chain reaction that unfolds over thousands of years. The planet inches toward a climate it was never meant to have. Or picture greenhouse gases rising just a tiny bit more each decade. The air holds on to more heat, the oceans absorb more carbon, coral reefs weaken, rain patterns shift, storms form in new places. Again, nothing seems world-ending in the beginning, but the slow climb creates a pressure inside the climate system, and eventually something snaps. Plate tectonics work the same way. Continents drift so slowly you would never feel them move, but their rearrangement changes everything. A continent sliding north by a few centimeters a year slowly blocks ocean currents. That changes heat flow across the planet. Temperatures rise in one place, fall in another. Rain belts shift. Winds change direction. After millions of years, the world is completely different from what it used to be. And then there is the quiet giant hiding beneath the crust. A supervolcano does not always start with shaking ground and roaring lava. Most of the time it begins with a small change in pressure deep underground. Magma collects slowly. Gases build up molecule by molecule. The chamber expands. Nothing on the surface reacts for centuries because the planet is patient. It waits until the pressure passes a threshold no one can see or measure, and then it erupts with more force than every human bomb ever made combined. When scientists study the rocks that formed during ancient catastrophes, they almost always find the same pattern. The beginning is subtle, the warning signs are soft, a slight change in temperature, a tiny drop in sea oxygen, a shift in the amount of pollen in a layer of mud. At the time, these signs were just whispers, but together they were the opening lines of a disaster story that would rewrite life on Earth. That is the terrifying part. The planet does not need explosions to break itself. It can fall apart quietly. It can drift into chaos without a single dramatic moment. Life continues doing what it always does, until one day the balance tips too far and everything changes so fast that nothing can adapt in time. The green skies and the dying oceans did not begin with a boom, they began with a whisper. A slow shift in forces older than any species on Earth. By the time the world realized what was happening, the disaster had already won. At first, the water only drops by a few centimeters each season, and no one pays attention. The tides feel a little lower. The beach feels a little wider. People living in the coastal village think it is just another strange year, but nothing to worry about. They keep fishing. They keep building their homes close to the shore. They do not see that the oceans are beginning to run from them. Far away in the polar regions, ice begins to grow thicker and heavier than it has in ages. When ice builds up on land, it traps enormous amounts of water that once belonged to the sea. The oceans shrink a little more each year, and the coastline creeps outward as if the planet is slowly pulling the water back into itself. In hotter regions, the opposite thing happens at the same time. Temperatures rise and shallow seas evaporate faster than storms can refill them. Water that once stretched for miles turns into salty mudflats. The air dries out. Winds pick up leftover salt and scatter it across the land until plants struggle to survive. Deep below the surface ocean, circulation begins to falter. Warm water that once flowed like a conveyor belt around the world starts to slow down. Cold currents weaken. The ocean becomes layered and still. This lack of movement makes it harder for oxygen to mix through the water, so animals begin fighting for breath even as the sea around them pulls away. Imagine a fish living in a shallow, warm bay that has been stable for generations. It swims through its familiar world without any idea that the water above it is shrinking a little every year. First, the sunlight gets brighter because the water is not as deep. Then the temperature rises. The oxygen drops. The fish swims higher, searching for cooler, safer places, but the bay is disappearing. The surface becomes hotter than it can survive. It cannot follow the water because the water itself is running out. Then imagine a coral reef that once exploded with color and life. Corals need stable conditions to grow and shallow seas to receive sunlight. When sea levels fall, the reef gets exposed to air in low tides more often. The corals bleach. They crack. They die. The fish that depended on them scatter into deeper, darker waters where predators wait and survival becomes a gamble. Back in the coastal village, people begin to notice something is wrong. Their boats scrape the sand where waves used to rise. The old fishing spots become fields of cracked earth. Every year, the shoreline crawls farther away, leaving abandoned piers pointing at empty space. The villagers follow the water on foot, wondering how fast they need to move to stay close to their only food source. No one realizes this is happening everywhere. Across the planet, coastlines surge outward at the same time as ocean basins fall quiet and life inside them weakens. The seas that once ruled Earth retreat like a giant animal curling away from the heat. The ocean does not roar as it disappears. It slips back inch by inch until whole communities and entire ecosystems find themselves stranded on dry land, staring at a waterline that keeps fleeing into the distance. The first thing you notice is the smell. It rolls across the water long before you see anything wrong. It is thick and rotten, like a mix of boiling eggs and dead fish, and something chemical drifting through the air. It clings to your clothes and settles on your tongue until you taste the decay with every breath. When a sea begins to die, it does not stay silent. It announces its collapse in a way no one can ignore. Warmth spreads through the water like a fever. As the ocean heats up, it cannot hold as much oxygen. Fish that once swam easily begin to struggle. They rise toward the surface, gasping like the air above them is their only hope. But the air cannot save them. The water below them is turning still and heavy. It is becoming a dead zone. Down in the darkness, the normal balance of life snaps apart. Bacteria that thrive in low oxygen explode in number. They feed on anything that sinks from above. Every dead fish, every falling plant fragment becomes fuel. These bacteria release gases that bubble to the top, turning the water into a churning brew of toxins. Then the algae arrive. At first, it looks like a faint green smear across the waves. Something small, something harmless. But then it spreads. It thickens. It grows into enormous blooms that stretch for miles. The surface turns into a glowing blanket of green or red, or even neon yellow, depending on the species. Sunlight hitting those thick layers makes the water shine with strange colors. In some places, it looks like the sea has been painted. In others, it looks radioactive. When the algae finally die, they sink and rot and steal even more oxygen from the water below. The dead zone grows larger. It pushes outward, eating the coastline like a slow, unstoppable infection. Fish flee. Crabs crawl onto beaches trying to escape water that is suffocating them. Birds that dive for prey find nothing but toxic slime. Everything that depends on clean water faces the same grim truth. This is not a place to live anymore. The sky reacts too. Tiny particles released by the dying sea rise into the air. They mix with moisture and sunlight, turning the sky into a reflection of the decay below. Instead of soft blues, you see hazy greens or dull yellows that make your stomach twist. Sunsets turn strange shades of red and sickly orange. Even the clouds look wrong, as if they are carrying pieces of the poisoned sea inside them. People living near the coast begin to feel the change. The air stings their eyes. The smell keeps them awake at night. Some days the entire horizon looks like a giant bruise spreading from the water to the sky. They hear stories from other towns telling the same thing. The sea is not just sick, it is dying. And the life that once made the oceans bright and full is being replaced by organisms that thrive in its collapse. This is what happens when water loses its breath. This is what a dying sea looks like, smells like, feels like, a living world turning into a silent one, while the sky watches and changes color to match its fall. The storms are the first thing that make people realize the world is shifting into something unfamiliar. They do not look like the storms you grew up with. They do not even move the same way. When the balance between land and sea breaks, the atmosphere reacts like a wounded animal, thrashing in every direction. The heat that once spread evenly across the planet begins piling up in certain places. Land that used to be cooled by ocean breezes now bakes under a sun that feels too bright. The sea, which once absorbed and released heat steadily, becomes sluggish and uneven. The difference in temperature between land and water grows sharper, and the air above them twists into violent shapes. One afternoon, the people in a drying coastal town hear a sound like a distant roar. At first they think it is thunder, but the sky is clear. Then someone points toward the horizon. A wall of brown is rising into the air like a mountain that was not there a moment ago. It climbs higher and higher, swirling and folding over itself until it stretches across the sky. It is a dust storm, but not the kind you see in old movies. This one is taller than skyscrapers and wide enough to swallow a city. The wind hits first. It comes in a sudden blast that knocks hats off heads and sends loose objects skidding across the ground. Then the dust reaches them. The sun disappears. The world turns a dark reddish brown. People cover their faces and run, but the dust finds them anyway, slipping into their eyes, their mouths, their homes. It scratches their skin and hangs in the air so thick it feels like trying to breathe through sand. Far out at sea, storms mutate into something even more terrifying. With warm water spreading farther than ever, hurricanes grow to sizes no one thought possible. They spin for days, feeding on the heat beneath them. Their eyes widen. Their winds scream at speeds that break instruments. When they finally hit land, they do not just destroy buildings. They reshape coastlines. They rip away forests. They carve new rivers through towns. Even after they pass, the air stays heavy and soaked like the world is still trying to catch its breath. In other regions, the opposite disaster strikes. Instead of hurricanes, they get mega monsoons, storms that last not hours but weeks. Rain pours down without stopping, turning streets into rivers and valleys into lakes. The ground becomes so soaked that entire hillsides slide away, carrying homes with them. People watch from rooftops as the world around them dissolves into mud. And then there are the heat storms. These are born when the land becomes hotter than the surrounding air, and the sky responds with lightning that cracks across cloudless skies. Winds spiral without rain. Temperatures spike suddenly with blasts of air that feel like someone opened an oven door. Animals collapse. Crops die. Even the night provides no relief. The weather no longer follows rules that humans understand. It lashes out without warning and fades without explanation. Standing in the middle of these new storms, people realize they are not just facing bad weather. They are witnessing the atmosphere becoming wild again, no longer the gentle blanket that once protected life, but a restless force shaped by a world that is overheating, drying out, and losing the stability it held for millions of years. These storms are not from the world they knew. They are from the world that is coming. The first sign that something is deeply wrong with the land is not a storm or an earthquake. It is the silence. The kind of silence that comes when the rain stops showing up. At first, people hardly notice. A mist shower here, a dry week there, nothing unusual. But the rain keeps failing, and the clouds keep drifting past without dropping a single drop. Entire months pass under empty skies. Grass that once brushed your ankles turns pale and brittle. Leaves curl into themselves, trying to hold on to whatever moisture they can find. The forests begin to lose their colour. What was once bright green becomes a faded yellow, then a dull brown. Trees that survive for centuries start dropping branches like they are trying to lighten their own weight. The air smells like dust and dry bark. Every step kicks up a thin cloud of powder. Rivers that have flowed for thousands of years shrink until they are nothing more than narrow ribbons weaving through cracked mud. Fish rot along the banks because the water became too shallow and too warm for them to breathe. Birds hop from stone to stone, searching for puddles that no longer exist. Some try to fly farther to find water and never return. Lakes disappear even faster. Shorelines pull back so far they expose old boat docks standing in the middle of barren flats. People walk on the lake bed and see sun-dried salt crystals crunching beneath their shoes. The lake that once stretched to the horizon is now a bright white desert, reflecting heat back into the sky. All of this is connected to the oceans. When the seas weaken and circulation collapses, the air stops carrying moisture inland. Storms that once travelled across entire continents now die before they reach the coast. The wind still blows, but it is empty. It has forgotten how to rain. Animals feel the change long before humans understand it. Herds begin migrating in chaotic patterns, leaving behind their traditional routes. They search for rivers that have not vanished yet. They dig at dry ground, hoping to reach groundwater that sank too deep for them to reach. Some species adapt by shifting their diets or travelling at night to escape the blistering heat. Others simply vanish. Their bones bleach under a sun that grows brighter every season. Even insects begin to fail. The buzzing that once filled summer days fades as bees collapse from heat and thirst. Without them, flowers struggle to reproduce, and crops begin to fail. Farmers watch their fields crumble into dust, no matter how much they try to save them. Communities that once thrived on fertile soil grow desperate. Wells turn to air. Groundwater sinks out of reach. People pack their belongings and move toward distant mountains, hoping streams still exist there. Entire towns empty as families chase rumors of rain. Some regions become unrecognizable. Hills turn to sand dunes. Forests become skeletons of what they once were. Valleys fill with dust storms instead of rivers. When land loses its rain, it loses everything that made it alive. The world grows quieter as life either adapts or disappears. In these places, you can stand under a clear sky for weeks without seeing a single cloud that carries hope. The land waits for rain that never comes, and the silence grows heavier with every passing day. In the fading forest, a small mammal steps carefully between dry leaves that crumble under its paws. It used to move through a world filled with shade and cool air, but now the trees around it are thin and brittle. The animal pauses to sniff the ground, searching for the scent of water. The streams it relied on have turned into dusty scars across the earth. Its tongue feels rough in its mouth, and every breath tastes like heated soil. It tries to dig where the stream once flowed, but the dirt breaks apart in its claws. There is nothing left. It lifts its head and listens for the sound of insects or birds or anything alive. The forest is too quiet. The silence tells it a truth it does not understand. Its home is dying, and it is running out of places to run. Far away in the shrinking sea, a shallow water predator circles the edge of a reef that no longer glows with colour. The coral beneath it has turned pale and dusty like bones scattered across the ocean floor. The predator used to hunt in bursts of motion, ambushing smaller fish that darted between corals. Now those fish are gone. The water is too warm and the oxygen too thin. Every stroke of its fins feels heavier than the last. It rises toward the surface, hoping for fresher water, but finds only waves coated with drifting algae. It opens its mouth to breathe, and the water stings its gills. The world it was born into is collapsing, and the deeper waters hold dangers it has never been adapted to face. The predator hesitates, then dives anyway, because staying means starving. High above the scorched land, a migratory bird beats its wings against a sky that feels hotter than fire. It has flown this route every year of its life, following ancient instincts passed down through generations. But now the wetlands it once used for resting are empty bowls of cracked clay. It circles them again and again, searching for anything green, anything wet, anything that means life. Its wings grow heavy, its breath grows thin. It pushes onward, hoping the next valley still holds what it needs. But the next valley is worse. The trees are dead. The lakes have disappeared. A gust of dry wind hits it with dust that burns its eyes. The bird lets out a call, not knowing no one will answer. It drops lower, looking for a patch of shadow, but the sun chases it without mercy. When it finally lands, its legs tremble. It tries to preen its feathers, but the dust clings to them and its beak feels too weak to finish. Extinction is not a sudden moment. It is a slow fading, where each creature reaches a point where there is nothing left to try. The mammal in the forest wanders farther from home until it no longer recognizes the land. The predator in the sea dives deeper and deeper until the darkness closes in. The bird on the cracked plain lies still under a sky that no longer gives life. These are not big, dramatic endings. They are quiet, personal, real. This is how extinction feels when it is no longer something from textbooks, but something happening to creatures one by one as their world changes faster than they can. At first, humans think they can handle the changes. We always believe we can engineer our way out of anything. When the coastlines start pulling back and the oceans grow, strangely silent, people treat it like an inconvenience, not a warning. Cities that once sat beside glittering blue water now overlook miles of cracked earth. Boat docks stretch into empty space like broken teeth. Fishermen walk where their fathers once sailed and stare at the dry seabed, wondering how the water vanished so far and so fast. Farms feel the impact next. Crops that depended on coastal rainfall begin to fail. Irrigation canals run dry. Soil that used to be rich turns to dust and blows away in the rising wind. Farmers pump groundwater until the wells cough up nothing but warm air. They watch entire fields collapse and know that no amount of skill can save soil that has lost its water forever. Governments pin their hopes on desalination plants. Machines that turn seawater into drinking water become humanity's last safety net. But as the oceans stagnate, those machines start pulling in water filled with algae, toxins, and strange chemicals rising from dead zones. Filters clog, membranes tear, the plants fail more often than they run. Cities that relied on them hold their breath every time one shuts down, because without them, millions of people have no clean water at all. Fisheries collapse one by one. Boats return empty. Processing plants sit silent. Entire communities that survived for generations on the ocean economy suddenly have nothing to trade, nothing to sell, nothing to eat. The global supply chain begins to fray. It does not break all at once. It snaps in quiet places first. A small port that used to ship seafood closes. A railway that carried grain rusts away because farms no longer produce enough to send anywhere. A shipping route shuts down because the port it connected to no longer has water deep enough for ships to enter. Megacities feel the impact next. These giant human hives depend on constant deliveries of food and water and fuel. When even one link in that chain breaks, millions feel it. Store shelves go empty. Prices explode. Water restrictions become normal. Entire neighborhoods line up at distribution centers with plastic containers, hoping the trucks still arrive this week. As coastlines retreat, trade becomes harder. Ships that once crossed deep blue oceans now face routes filled with unpredictable storms and shallow passages. Ports built to handle massive cargo vessels must rebuild miles inland, but the money and time required are more than many nations have. People begin to leave the cities. Some move inland, chasing rumors of better farmland. Others head toward mountains, hoping to find streams that have not dried up yet. Highways fill with families carrying everything they can in cars that overheat in the new heat waves. Society changes from the inside out. Old systems no longer work. New ones are rushed together out of desperation. Water becomes the most valuable resource on the planet. Nations argue, fight, and negotiate in the same breath, trying to secure access to rivers that are shrinking every year. The human experiment starts to look fragile. Our cities were built on the belief that oceans would stay where they were and that water would always be there when we needed it. When those foundations fail, we see how quickly everything else follows. Humans are adaptable, but even we struggle when the world we built no longer matches the world we live in. At first, people think it is just another bad air day. Cities have dealt with smog for decades, so when a weird haze settles over the skyline, most people shrug it off and head to work. But by late afternoon, the sunlight starts changing colour. It bends and scatters through the haze until the sky above the buildings turns a sick shade of green mixed with bright orange streaks. Phones come out instantly. Videos explode across social media. People laugh nervously while filming themselves under the strange glow. Some joke that aliens have finally arrived. Others swear the world is ending. The views climb into the millions before night even falls. Governments release short statements telling everyone to stay calm. They blame forest fires at first. Then they blame industrial accidents. Some leaders argue with each other, live on camera, insisting the strange sky is not their fault. No one knows the truth because the data coming in is confusing. Satellites show massive clouds of dust traveling across continents. Sensors pick up unusual compounds in the air that do not match any known pattern. There are hints of biological aerosols, strange microscopic fragments that look like they came from algae blooms rising off dying seas. Nothing makes sense yet. The green sky spreads across cities that are nowhere near each other. One day it covers Seoul, the next it hits Los Angeles. Then Berlin wakes up under the same unsettling light. It becomes clear this is not a local event. The haze is riding global winds carried from ocean to ocean and desert to desert. People start noticing changes in the way the air feels. It is heavier and slightly sour. Some say it tastes metallic. Others say it smells like wet soil and chemicals mixed together. Children point at the sky because they know deep down something is not right. News anchors try to stay calm, but their voices shake when they show maps with swirling green-tinted plumes drifting across the atmosphere like bruises spreading on the skin of the world. Scientists warn that the sky is acting like a giant mirror, reflecting sunlight in strange directions. Temperatures swing wildly from one day to the next. Shadows look distorted. Sunsets last longer than they should, glowing with neon greens that make the horizon look radioactive. People stop going outside unless they have to. Streets that were once filled with life become quiet. Schools close. Some wear masks even indoors, hoping to block out whatever is floating in the air. Everything feels dreamlike. Not dangerous enough to cause immediate panic, but unsettling enough that no one can relax. Over time, a slow realization spreads. The haze is everywhere. The sky does not clear even on windy days. Rain falls in odd colors, sometimes brownish or faintly green because of the particles it drags down. This is not a storm that will pass. This is not pollution trapped over a single valley. The entire atmosphere is changing. When the truth finally sinks in, people across the world feel the same cold fear. This is not weather. This is not an accident. The green sky is a signal that the planet has entered a new state, and civilization is standing beneath a warning written across the heavens in colors no one alive has ever seen before. In labs around the world, the atmosphere feels as tense as the sky outside. Scientists who were once used to quiet routines now move with the urgency of people trying to solve a puzzle while the room around them burns. Screens glow with satellite images showing the green haze swirling across continents. Data streams from ocean buoys look broken, filled with strange temperature spikes and oxygen drops that no one can explain. Deep-sea probes send back videos of murky water rising from the darkness, like smoke drifting upward. Every lab sounds the same. The hum of machines, the tapping of keys, the low voices of researchers arguing over numbers that refuse to behave. Models are run again and again until the computers overheat. Each simulation ends with the same impossible conclusions. If this were a normal climate event, it would have cleared by now. If it were pollution from fires, the winds would have scattered it. If it were a volcanic blast, sensors would have picked up a signature buried in the ash. None of those things fit. That only makes everyone more scared. In one observatory, a young researcher rewinds satellite footage from earlier in the year. She notices that the haze did not begin in a single location. It appeared almost everywhere at once, in thin streaks that slowly thickened. It spread the way a shadow spreads, not the way smoke does. Her supervisor leans over her shoulder and frowns. They both know that means the cause is not local, it is global. In another lab, a team studies rainfall samples collected from different continents. The water contains particles that look biological, but not from land. They resemble fragments from massive algae blooms, but altered by extreme heat. No one understands how those particles reached the upper atmosphere. Someone suggests the oceans might be releasing them during deep overturning events. Someone else argues that the oceans are too stagnant for that now. They all fall silent when they realize what that implies. Something unknown is stirring the water from below. Mistakes pile up in the chaos. One group publishes a paper claiming the green sky is caused by a rare atmospheric reaction to ultraviolet light. Another team proves the math behind that idea is off by a factor of 100. A third team announces that the haze comes from desert dust. Hours later, they retract the claim after finding oceanic compounds in the samples. It feels like everyone is chasing answers in the dark. But then a faint pattern begins to show itself. A geologist pulls up records from ancient mass extinction events. He compares the chemical signatures from those eras to the haze particles drifting through the atmosphere today. The room goes quiet as the graphs line up almost perfectly. These same compounds appeared during a catastrophic period hundreds of millions of years ago when the oceans stagnated and the skies took on strange colours. A climate modeller runs a long-term simulation including those ancient conditions. The result sends chills through the team. The model recreates the exact green-tinted sky forming now. The same stalled ocean currents, the same oxygen drops, the same worldwide haze. One scientist whispers that they are not witnessing something new. They are watching history repeat itself. Panic settles into the labs like another layer of haze. They know what the planet is doing because it has done it before. The difference is that this time humans are here to watch the beginning and wonder if they will be here for the end. Long before humans walked the Earth, the planet went through disasters so extreme that life almost vanished entirely. The most terrifying one happened during the Permian extinction around 252 million years ago. Scientists call it the Great Dying because it wiped out nearly every species in the ocean and most on land. When you look at the rock layers from that time, you see the same haunting signals appearing in the world today, and it feels like the past is reaching forward to warn us. Back then, the sky changed in ways no creature had ever seen. It shifted into strange, hazy colours, not because of pollution from cities, but because the atmosphere filled with volcanic gases and aerosols rising from massive eruptions that lasted for thousands of years. Those eruptions released carbon dioxide and methane into the air so fast the climate could not adjust. Temperatures soared. The oceans warmed until they could no longer hold oxygen. Whole layers of the sea turned into suffocating dead zones. Fish and shell creatures collapsed first. Coral reefs disintegrated. Even microbes struggled to survive in the thick, toxic water. The surface of the ocean changed color too. It became cloudy and greenish in massive patches where bacteria and algae took over. Sunlight filtered through the haze above and the murky water below, twisting the sky into shades that would have terrified anything living at the time. It was not just the oceans that suffered. On land, forests collapsed as heat and drought spread across continents. Rivers dried up, deserts expanded. Animals tried to migrate but found nothing ahead but more heat and empty land. The air grew heavy with sulfur and ash. The entire planet felt like it was slowly suffocating. What makes this even more unsettling is that scientists now see almost identical chemical signatures appearing in the haze drifting across the modern world. The same compounds that colored the skies during the ancient extinctions are showing up in today's atmosphere. The same oxygen drops are appearing in the oceans. The same bacterial blooms are spreading in warming coastal waters. During another ancient collapse, millions of years after the Permian, the oceans retreated in some regions just like they are now, beginning to shrink along certain coastlines. The rock layers from those times show signs of severe evaporation and exposed seafloors that match the patterns researchers are finding in dried-up bays and vanishing lakes. It is like the planet is following a script it has used before, one that always ends the same way, with ecosystems falling apart and life struggling to survive. The echoes from those ancient disasters are everywhere once you know how to read them. When scientists compare modern data to the old extinction records, the lines overlap again and again until it becomes impossible to call them coincidences. The atmosphere is changing in the same direction. The oceans are reacting with the same symptoms. The skies are taking on the same eerie shades. This is what scares researchers the most. Not that the world is acting strangely, but that it is acting exactly the way it did during the worst collapses in Earth's history. The past is not just a memory, it is a mirror. And what it shows us is a planet that has already walked this path once and barely survived. The question now is whether humans understand the danger in time, or whether we become another line in the long record of extinctions carved into the bones of the Earth. A tipping point is one of the most dangerous ideas in nature because it does not act the way people expect. Most of the time we imagine the planet changing slowly, like a dimmer switch turning down little by little. But tipping points do not work like that. They act more like a canoe on a calm lake. You can lean to one side slowly and nothing happens. Lean a little more and still nothing. But the moment you lean past a certain angle, the canoe flips instantly and there is no way to stop it once it starts. Earth has places and systems that behave exactly the same way. Ice sheets in Greenland and Antarctica melt slowly at first, then suddenly pass a point where the melting speeds up so fast the ice cannot recover, even if the temperature stops rising. Forests like the Amazon survive drought after drought until one day they hit their limit and shift from a living rainforest into a dry plain. Ocean currents move steadily for centuries until the water becomes warm or salty enough that the circulation snaps and stops like a broken engine. These shifts are not gentle, they are sudden and permanent. Once they flip, they cannot flip back. Scientists fear these tipping points because they do not happen alone. One tipping point pushes another. Think of a row of standing domino pieces. Each piece looks stable, but if one falls, it knocks the next and sets off a chain reaction. Earth works the same way. When ice sheets melt, they pour fresh water into the ocean. That fresh water slows down major currents. Slower currents mean less movement of cold and warm water. Less movement weakens oxygen mixing. Weak oxygen mixing leads to more dead zones and more greenhouse gases released from the deep. Those gases warm the atmosphere even more, which melts ice even faster. Another example comes from forests. When a forest dries and burns, it releases carbon into the air. That carbon heats the planet. The heat causes drought in other forests. Those forests burn too, and the cycle repeats, growing worse each time. In these moments, the planet does not behave like a smooth line on a graph. It behaves like a glass hitting the floor. 1 second the glass is solid, the next it shatters into pieces. There is no in-between. Humans are not used to thinking in tipping points. We think in slow changes. We think we will have time to react, but the planet does not always give warnings. Sometimes the shift happens quietly until the final moment when everything breaks at once. When scientists look at the modern world, they see signs that multiple tipping points are nearing their limits. Ice melting faster than models predicted, forests losing moisture at record speed, ocean currents slowing in ways that once seemed impossible. The scariest part is how connected they all are. One does not need to collapse completely for the next to weaken. They only need to tilt a little. Once the first tipping point flips, it can drag another with it and another after that. The danger is not just one system failing. It is the possibility of watching many of them collapse in a single human lifetime. That is the true fear behind tipping points. Not the moment they flip, but how quickly everything connected to them follows. In the heart of the dry belt, the world feels like a place that forgot what water is. The old ocean lies far beyond the horizon, leaving behind miles of sun-baked salt flats that shimmer like broken mirrors. Nothing grows out there. Nothing moves. The wind lifts dust in thin spirals that vanish almost as quickly as they appear. The air is so dry it pulls moisture from your skin the moment you step outside. People learned early that surviving here meant bending their entire lives around the idea of saving water. Cities did not vanish. They changed. The first dome cities rose from the ground like giant glass bubbles built from materials that reflect heat and trap moisture. Inside, the air stays cool and the light is controlled, so nothing evaporates faster than it should. Buildings are stacked tightly together, and walkways are lined with condensation panels that collect every bit of breath, sweat, and humidity drifting through the air. Nothing is wasted, not a single drop. Families live in small apartments designed to recycle nearly all their water. Showers are short and use mist instead of streams. Toilets hardly use water at all. Even cooking is done with machines that reclaim the steam rising from boiling pots. At first, people hated it. It felt strange and strict and unnatural. But this is what survival looks like in a world where rain is no longer guaranteed. Outside the domes, life continues too. Some communities build underground homes carved into ancient seabeds where the temperature stays cool enough to live without ovens of sunlight burning overhead. Down there, the walls glisten with collected moisture captured by stone that grew porous after centuries of dry wind. Pipes run like veins through these tunnels, carrying recycled water to small farms lit by artificial suns. Crops grow in layers stacked like shelves, thousands of tiny plants rooted in nutrient gel instead of soil. Workers move quietly through the rows, checking routes, adjusting lights, and whispering to each other, because in places like this, even sound feels fragile. Farmers in the dry belt do not wait for rain. They build machines that pull water from the air even when the humidity is so low it cracks lips and dries eyes. Massive towers stand outside the dome walls, covered in special materials that draw in moisture the way cold drinks fog up in warm rooms. The collected droplets slide down into underground reservoirs, protected from the heat. It is slow but steady, enough to keep people alive. On the far edge of one settlement, a group of teenagers rides bikes along what used to be a harbour. Their wheels crunch over salt where waves once rose and fell. They cannot imagine the ocean touching this place. To them, the dry belt is normal. It is home. They grow up learning to carry water filters in their backpacks and treat every cup as something precious. At night, the sky over the dry belt glows with stars brighter than anywhere else because there is no moisture left to blur them. People sit under the domes or outside on rock benches and watch the sky shimmer while machines hum softly in the background, collecting water molecule by molecule. Life here feels like science fiction, but it is real. It is the future shaped by a world that dried out faster than anyone expected. And even in this harsh new reality, people adapt because that is what humans have always done. The dust comes back the same way all things do in a world running out of water. Slowly at first, like a whisper across empty fields. Then all at once, like a planet remembering an old habit. With the oceans pulled back and the rains fading away, the land transforms into a giant source of loose earth. Plants that once held the soil in place have died or retreated into rare pockets of green. What remains is dry ground waiting for the smallest gust of wind to lift it into the air. At first, the dust moves in small clouds that dance above the cracked land. They drift across abandoned farms and dried riverbeds without much notice. But as the drought deepens, the clouds grow larger. They join together into long ribbons that stretch for miles. The wind strengthens and lifts them higher until the dust rises into the sky like a second atmosphere. Satellites begin to pick up strange patterns. From space, the planet no longer looks blue and green. Instead, swirling beige bands wrap around the continents like scarves made of desert. They drift across oceans and mountains without slowing down. It does not matter where they start. Once the dust reaches the upper air currents, it becomes global. Every sunrise looks softer as the dust scatters the light. Every sunset glows longer and stranger, with colours that shift between orange, green, and dull red. People try to capture it on video, but cameras cannot show the full effect. The world below the sky feels muted. The brightness of day dims. Shadows turn fuzzy. Even the air tastes different. Grit collects on windowsills and in the corners of rooms. The dust is not just dirt. It carries fragments of plants, bacteria, and tiny minerals lifted from dry seas and ancient lake beds. Every breath carries a piece of places you have never seen. The sky becomes a canvas for this mixture. When sunlight passes through layers of dust, the colours bend in ways that make the horizon look unreal. Some days the sky is pale gold that never quite reaches blue. Other days it is a washed-out green, reflecting the aerosols drifting at higher altitudes. Scientists explain that dust changes how clouds form. Moisture that normally gathers into raindrops now clings to particles of dust. This creates thin clouds that drift apart instead of growing heavy enough to fall as rain. The more dust, the fewer storms. The fewer storms, the more dust. It is a loop that accelerates with every passing season. People living in cities far from deserts find themselves sweeping dust from their doorsteps every morning. Schools cancel outdoor sports because visibility drops when the wind picks up. Cars move with their headlights on in the middle of the afternoon because the sky looks like it is trapped in permanent twilight. Some days giant walls of dust rise on the horizon. They move so slowly at first that you cannot tell they are coming. Then the wind carries them faster until the sky disappears behind a towering curtain of brown. It rolls over highways and forests and empty fields until everything is swallowed in darkness. This is the return of the dust world, a planet wearing a mask of its own broken soil. The sky above is no longer just a reflection of light. It is a living record of everything the Earth has lost, carried grain by grain across a world struggling to breathe. When a planet changes this fast, it feels like everything is ending. The oceans shrink into distant memories. The forests fade. The skies fill with colors that make people nervous to look up. From the surface, it seems like Earth is shutting down one ecosystem at a time. But the planet has been through disasters far worse than this, and every time life has found a way to survive somewhere. Maybe not everywhere, but somewhere. Even now, when the coastlines have fallen back and the rain barely shows up, there are pockets where life hangs on with stubborn strength. High in the mountains, where cooler air still holds a little moisture, mosses cling to rocks that drip with the last traces of melted snow. Tiny insects crawl between them, moving slowly to save energy. Small animals hide in narrow cracks where the temperature stays steady. These creatures do not know the world is collapsing below them. They only know they have found a place that gives them just enough to continue. Far underground, another refuge thrives in complete darkness. There are caves so deep and old, their walls still hold moisture, trapped from ages when the world above was wet and green. Inside these caves, strange forms of life glow faintly on the stone surfaces. Fungi spread across the rock, eating minerals and feeding small blind insects. Tiny pools collect water that has been dripping for decades. In these hidden places, the outside world might as well be another planet. While the surface burns and dries, the underground stays calm, patient, and alive. Even in the oceans, where the upper layers are suffocating, pockets of resilience appear. Deep-sea trenches remain dark and cold, the way they always have. The pressure there is so intense that it crushes anything not adapted to it, but that same pressure protects the deep from rapid change. Life in these trenches moves slowly and needs little oxygen. Giant tube worms perch near vents that spit out warm, mineral-rich water. Odd fish with glowing eyes drift through the dark as if time cannot touch them. They feel the change above only faintly, like a distant echo. They do not know the oceans are dying. They only know their world continues. On the edges of deserts where drylands push farther every year, a few stubborn springs still flow. They bubble from cracks in the rock fed by ancient groundwater buried deep below the surface. Around these springs, life gathers in tiny oases. Plants with deep roots drink carefully from the damp soil. Animals travel miles through dust to take mouthfuls of water that keep them alive for one more day. Birds rest in the shade of these rare green spots before continuing their long and dangerous journeys. The planet is not dead, it is in shock. It is reorganizing itself the way it has during every massive climate shift in its history. Life retreats into the corners. Where conditions remain tolerable, it shrinks, it hides, it adapts. And when the world stabilizes again, even if it takes thousands of years, life will grow outward from these strongholds and reclaim what was lost. Earth is not a fragile world. It bends and twists under pressure, but it does not break. The creatures that survive these times will be the ones flexible enough to change with it and start new chapters of evolution that no human today could imagine. When an ocean collapses, it does not return in a single heroic moment. There is no giant wave rushing back to refill the empty seafloor, to no sudden burst of life that restores what was lost. The comeback of a dying ocean is slow, almost unimaginably slow measured, not in human years, but in the patient language of thousands and millions. At first the world is quiet. The old coastlines lie far inland, and the remaining water is shallow and hot, barely able to hold oxygen. The surface is covered with dust and drifting algae that survived the chaos. Most large creatures are gone. Whales, seals, sharks, all the giants that once ruled the sea are missing because the base of the food chain collapsed. But the ocean does not stay empty forever. It begins with plankton, tiny organisms so small most people never notice them. These microscopic drifters are the first to return because they need only sunlight and water to survive. They float across the warming sea, building fragile shells and capturing bits of carbon. They multiply slowly at first, then faster as the water clears and stabilizes. With them come other small forms of life, tiny crustaceans, jelly-like creatures, and strange worms drifting in from deep refuges. Each new species adds a layer to the rebuilding food web. While this is happening, the planet itself keeps shifting. Tectonic plates continue their ancient march, grinding continents together and pulling them apart. New mountains rise. Old sea basins sink. Over thousands of years, fresh cracks in the crust open new waterways and reconnect isolated pools. Rain eventually returns in some regions, washing minerals and nutrients back into the sea. Rivers carve through dust plains once more, bringing the ingredients needed for life to grow. As the climate stabilizes, ice sheets shrink or regrow depending on the cycle. Their meltwater changes ocean levels again, flooding old valleys and creating new coastlines. The sea breathes in and out, reshaping the planet's edges in slow tidal pulses that last centuries. With deeper water and cooler temperatures, oxygen starts to return to the ocean depths. The dead zones shrink. The layers of still water begin to move again, pushed by winds that carry fresh patterns of heat around the planet. The great ocean conveyor, the system of currents that moves water across the globe, starts to wake up from its long sleep. It does not flow strongly at first. It twitches, it hesitates. But eventually it finds its rhythm, and the sea begins mixing again, breathing again. Coral reefs do not come back quickly. They are among the last to recover. But hardy pioneer species take hold on bare rock, small branching corals that can survive unstable conditions. Fish that never left the deep edges venture back into shallower water. Their populations grow as the food web strengthens from the bottom up. Sharks and larger predators return only much later, after the ocean has proven it can support entire chains of life again. The giants rise last because they require the strength of an entire ecosystem beneath them. Millions of years after the collapse, the ocean becomes unrecognizable compared to the one that nearly died. New species dominate waters that once held old familiar forms. New coastlines shape new currents. Life fills every depth again, from shimmering schools near the surface to strange glowing creatures in the trenches. The ocean does not return to what it was. It becomes something new, built on the bones and memories of the world before. That is the quiet miracle of a recovering planet. Even after disaster, even after everything collapses, the ocean finds its way back, not through drama, but through persistence, starting with the smallest creatures drifting on currents that slowly relearn how to flow. When the sky finally begins to heal, there is no announcement, no sudden shift, no dramatic return of colour. It starts with a faint change that no one would notice unless they were looking for it. The green tint that once hung over the horizon softens by a shade. The dust in the upper atmosphere thins just enough for sunlight to scatter more naturally. The world is still harsh and strange, but the air above it is beginning to remember how to be blue. The atmosphere repairs itself through slow, ancient processes that have worked since the beginning of Earth's history. Rocks exposed on new coastlines start pulling carbon dioxide out of the air as rain and wind grind them down. Each grain of weathered stone locks away tiny amounts of greenhouse gases, removing them from the sky one molecule at a time. It is the planet's oldest cleanup system, and it never truly stops, even during the worst disasters. Forests begin to regrow too, but not where they once stood. Old rainforests now lie silent and dry, their skeleton trees bleaching under long dead sunlight. Instead, new forests appear in places that were once too cold or too barren. Seeds carried by wind take root in fresh soil, formed from centuries of dust buildup. Small shrubs grow first, then hardy trees that can survive wild temperature swings and uncertain rainfall. As these new forests spread, they breathe in carbon dioxide and breathe out oxygen, slowing the planet's fever little by little. Oceans join the recovery once their circulation returns. As deep waters mix again, they pull down enormous amounts of carbon dioxide and bury it in sediments. Plankton populations grow stronger, filling the water with fresh life. Their shells fall to the seafloor, trapping more carbon beneath the waves. This slow dance between air and sea gradually balances the atmosphere again, smoothing out the chemical scars left by centuries of collapse. High above all this change, the sky shifts in delicate stages. The thick beige belts of dust circling the planet fade into lighter veils. Storm winds sweep the lower atmosphere clean more often. Rain returns in scattered patterns, washing particles back to the ground. After thousands of years, the haze that once wrapped the earth like a bruised halo thins enough for true color to reappear. The green becomes pale. The orange fades. A soft grey blue emerges at the edges of dawn like a memory returning. Eventually the world wakes up to a sky that looks almost familiar. Not the exact blue that humans once knew, but a new shade shaped by a changed atmosphere and changed sunlight. It is gentler and slightly cooler in tone, the colour of a world rebuilt from the inside out. But beneath that softening sky, the planet is nothing like the one that existed before. Coastlines carve new shapes across continents. Valleys once drowned under water now cradle young forests. Old ocean floors lie exposed as plains filled with strange plants. Species that survived the collapse evolve into new forms, with new behaviors shaped by the harsh years their ancestors endured. Life does not return to the old world. It grows into a different one. The sky turning blue again is not a sign of things going back to normal. It is a sign that the planet has entered its next chapter. The storms have quieted. The haze has faded. The atmosphere breathes more easily. And under that wide blue ceiling, a reimagined Earth begins to settle into its new identity, shaped by disaster but not defined by it. Far in the future, long after our cities have crumbled and our languages have vanished, a different kind of scientist kneels beside a cliff made of layered stone. Maybe they are human descendants, shaped by a different world, or maybe they are another species, entirely one that rose long after we disappeared. They chip at the rock with careful hands, exposing a thin band of material pressed between ancient layers of sand and clay. The band is strange. It glitters with tiny pieces that do not belong in nature. Some look like threads, some like shards, some like smooth, colourful grains. The scientist does not know the word plastic, but they can tell this layer is unlike anything else in the entire cliff. It is the line that marks our time. Above it, the stone looks warped from rapid climate swings. Below it, the rock shows signs of calmer ages when oceans were full and forests thick. But in this thin band, a whole story is trapped. Radionuclides appear where they should not be. The scientist measures them and sees isotopes that only form during high-energy reactions, the kind that come from weapons tests and melted reactors. Some of those isotopes decay quickly and should have vanished long ago. Yet faint traces remain locked inside tiny grains of fused sand, suggesting events violent enough to leave scars that lasted ages. The scientist moves their light closer and sees microplastics scattered through the layer like confetti frozen in time. They appear in every colour. Some are curled like fibres. Some look like the remains of containers or tools. Mixed into that plastic dust are chemical signatures that hint at fertilizers, pesticides, and industrial compounds. These molecules form a pattern the scientist has seen before when studying past mass extinctions, except this one is sharper, more sudden, almost like the planet inhaled something poisonous in a single geological breath. And then there is the carbon. The scientist crushes a piece of the layer and analyzes the gas released from it. the ratio of carbon isotopes is wildly skewed. It shows a spike so steep it looks more like a cliff than a curve. In their world, no natural event can explain such a sudden jump. Volcanoes do not do this. Meteor strikes do not do this. This is the signature of something burning at a global scale. The scientist makes notes on a tablet carved from synthetic stone. They write about a period when temperatures rose at incredible speed and oceans dried back from their coasts. They describe dust storms covering continents and strange aerosols changing the color of the sky. They record signs of rapid species loss, followed by a slow recovery, just like earlier extinction events, but faster and more uneven. At the very bottom of the band, they find shapes that resemble the outlines of buildings pressed flat by time. Not full structures, just impressions of straight edges and smooth curves. Nature rarely makes shapes like these. The scientist sits back and looks at the cliff stretching high above them. This thin band filled with glittering fragments and chemical fingerprints marks a moment when something powerful lived on Earth. Something that changed the planet quickly, then vanished. They call it the brief human epoch, not because of its length, but because of how loudly it speaks through the rocks. A civilization that burned bright enough to mark the planet forever, yet short enough to fit inside a layer no thicker than a finger. What the rocks say about us is simple. We changed the world. We left a trail of plastic carbon and radioactive dust that future eyes will study long after we are gone. Our entire story pressed into stone, waiting to be read by whatever life comes next. The first rule of surviving a green sky is knowing that it never starts with the sky. It starts with tiny things. Changes so small they look harmless. A warm year, a strange storm pattern, a shift in the color of the ocean. These are the whispers that come before the world raises its voice. Every major catastrophe in Earth's history began with something quiet. The planet leans a little, the currents slow a little, the air warms a little. Then those little shifts build on each other until the system flips and the sky turns a color no one has words for. The lesson is simple. Pay attention early. Act early. Waiting for certainty is how species disappear. The second rule is to understand that survival is a team sport. No creature has ever survived a global shift alone. During the ancient disasters, the species that lived were the ones that cooperated. Groups that shared food lasted longer. Creatures that learned together adapted faster. Early humans only survived their own near extinctions because they pooled knowledge and protected each other. When the sky turns strange and the world grows unstable, cooperation is not optional. It is the only reason any species makes it through. The third rule is to trust science, because science is just the act of listening to the planet carefully. Satellites are ears, sensors are eyes. Models are a way of imagining the future before it arrives. They are not perfect. They make mistakes. But mistakes do not mean useless. They mean learning. Every time the world shifts, scientists look backward at the rock layers and the fossils and the old chemical records. Those records say when danger begins and how fast it spreads. They also show that recovery is possible, but only if living things adapt before the tipping points lock in. The fourth rule is to adapt without pride. The animals that survived ancient collapses were not the strongest or the fastest. They were the ones willing to change their habits, to move to new places, to eat new food, to live in unfamiliar environments. Humans are no different. Cities might need to move. Farming might need to transform. Water use will need to become careful and creative. Technology will matter, but only if it grows alongside behavior that respects the limits of the world we live in. The fifth rule is philosophical, but important. Do not mistake change for the end. When the sky goes green and the oceans pull back, it feels like the world is dying. But Earth does not die. It reorganizes. it becomes something new. The species that survive are the ones that accept the world as it is becoming, not the world as it used to be. Survival is not holding on to the past. It is stepping into the future with open eyes. The sixth and final rule is this: hope is a tool, not a decoration. Hope does nothing on its own, but combined with cooperation, science, and adaptation, it becomes a plan. It becomes action. It becomes the reason species make it through dark chapters in Earth's story. The green sky is not a prophecy. It is a warning, and warnings are gifts. They mean there is still time to act, still time to adjust, still time to choose a future instead of falling into one. This is the manual for surviving a green sky. Listen early, work together, trust knowledge. Adapt fast, respect the planet, use hope as fuel. Everything that survived before followed these rules, even if they did not know it. Now it is our turn to do the same. Right now, if you look up, the sky above you is still familiar. Maybe it is bright blue. Maybe it is pale or a little hazy from traffic or wildfires. Maybe clouds drift across it in slow white sheets. Whatever it looks like, it is still a sky you can breathe under without thinking. A sky that still protects you more than it threatens you. That alone is a gift, and it is easy to forget how fragile that gift really is. Earth has been through disasters that almost erased life completely. Skies that turned colours no living eyes had ever seen. Oceans that stopped breathing. Continents that dried out and cracked apart. Yet the planet found ways to rebuild itself every time. It healed. It adapted. It created new worlds on top of the old ones. But here is the part we cannot ignore. The creatures that survived those ancient collapses did not survive because they were invincible. They survived because they changed fast enough. They noticed the warning signs even if they did not understand them. They moved. They adapted. They let go of what was normal and learned how to live in what came next. We are living at one of those hinge moments right now. Not in some distant future. Not in a documentary someone will make centuries from now. Right now, in the years you are alive. The oceans are warming faster than at any time in human history. Ice is melting in places that were frozen since long before humans existed. Forests are burning in seasons that used to be safe. Species are disappearing quietly as the world around them shifts faster than their instincts can keep up with. These are the whispers before the shout, the tiny cracks before the tipping point. But the sky above you is still blue enough to matter. The air is still breathable. The oceans still have life. The forests still grow. That means the story is not finished. It means there is time to choose a different path than the one carved into the rocks from past extinctions. When you step outside and look up, it is not just empty air. It is a reminder that you are living in a rare moment, a moment where the future is not locked in yet. A moment where what humans decide to do or not do will echo for thousands of years. The sky has turned strange before. It has turned red from volcanic ash, and green from dying oceans, and brown from dust worlds rising out of drought. But each time it eventually healed. The question now is whether we stay part of that healing or become another thin line in the rock record, waiting for someone far in the future to discover and wonder what happened to us. The sky above you is ordinary in the best possible way. It means the planet is still giving us a chance. It means the world has not crossed all its tipping points yet. It means that what we choose to protect now will decide what future skies look like. So look up, really look. That colour that seems so normal is a reminder of everything still worth saving.